Hello friends and hello student. My name is Ashok Srijala. In this session we learn the given number is magic or not in C++ and recursive digit of sum. That technique we have to apply. So first let us share my laptop screen and fix the position here so you can watch better my video lecture. And here turbo C++, I double click and take some process. And now yes, get open Alt F file menu, taking new file, and here our goal, write a program to enter one integer, integer number and check that number is magic, yes, magic or not using recursive sum of digits. Yes, that is our technique, means recursively logic. So function call itself that call that known as a recursive. So I give second line so you can watch in one screen. Yes, sir. So in first in your mind, what is a magic number? Yes, so here what first what is a magic number? Yes, that question I give the answer. So magic number is a number that we can recursively sum of digit at the last single digit and that getting the one. So that is a magic number. Otherwise, that number is not a magic number. So let us, if you not understand, then I give one example. So like 50113, that is a magic. Why? 5 plus 0 plus 1 plus 1 plus 3. So that is a sum of 10. And again continue this process sum, and that is recursive digit of sum and then 1. Yes, that number is magic. So at the last of the digit, single digit, we can convert to our number. Continue this process. So that is a magic. Second example, yes, so 1, 2, 3, 4. Yes, that is also magic. 1 plus 2 plus 3 plus 4. So that is also getting 10. And 1 plus 0. So again 1. So that is a magic number. Now three digits. So 640. Yes, that is also magic. 6 plus 4 plus 0. So again 10. And 10 is a, now sum is last as 1. So that is a magic. Yes, 3, 5, 2. Yes, that is also magic. 3 plus 5 plus 2. So again 10. Yes, that same. 1 plus 0. So that is a 1. So that is a magic all number. But now in your mind question, how? So like you do not one magic number. So 1, 2, 3 is not magic because that sum of digit is 6. So that is a perfect number. So yes, that I remove. So yes, here all that is, now you can get the idea what is a magic. So we can apply this logic and I give multi-comment line to your reference. That type of we have to check that number is magic, and we can use UDF, user defined function. But first I write in the main directly. So our header file, that is io stream.h. Yes, and then can take as conio console input output, and now void main. And next you can also apply the class, but here simplicity I can take first in directly main. So it is a number and digit and sum to assign 0. Three variable we have to take, and then we can enter first, that is enter one integer number and then scan scene, see out and scene you have to know very well. So yes, here, yes, that is a first what is a input. Yes, that is a technique. So here I give like input, then process, and then that is output. So divide and conquer in three parts. What is the input? So here that enter one integer number, is our input, and find out that number is magic or not, that is our output. And how to find out, that is process, and that is a logic. So yes, first part we can scan our one integer number, and now I take as while loop, and then you can say that n is greater than. So while loop is a best. So like Armstrong number, palindrome number, uh, prime number, factorial number, so many number program you can apply the while loop, because we have to not get any starting, any ending iteration. So that time we can use as a while loop. This while loop is the best for number programming. And now I give the logical AND operator, and sum is two digits start after 9, so greater than 9. So some student that in magic number that taking two digit sum and two while loop, three digit getting the first time sum that taking three while loop. So that is not solution, that is a logic in the magic number. So here we can apply perfect one only while loop. Yes, that is uh, possibility. So like n equal to 0. So continue that same while loop. We cannot take other while loop or any one or two. So here only one while loop, not two or three, four. Yes. So any digit number of sum you can get first and continue this while loop as same. So that is a very short logic I can apply. So here while, how continue. So n equal to, so at the last or while loop false, then n is greater than 0. But if that is a if 0, so that while loop means false. But sum is greater than 9, so that continues same while loop. So that is our goal. And now what to do? So n assigned to sum. So that is a sum is now that you can look here. Our first time we can get 10 of digit sum, so that is our new number. And again, we can continue this sum of this new number. So I can assign the sum as n and sum assigned to 0. So that is a, we can assign one variable to other, and then our sum is assigned again. So here first time we can assign the 0. So then same assigned to uh, our new number as assigned to n and sum assigned to 0. That is our logic. And now we can take process. So digit we can separate, modulo operator. So that is a separate, and sum uh, plus equal to d for digit. So that is a compound assignment. That full form sum equal to sum plus d. I think you have to know very well. So here one statement, that is same one variable used two times. So you can apply the compound assignment operator short technique. And again I use short technique, n divide by equal to 10. So that is a full form, n equal to n divide by 10. So that is also compound assignment operator. So yes, at the last we can take if, and sum we can get equal to 1. So we can print a message, the number is magic number. Yes, and as part, if 1 we cannot get the sum 1, so we can say that number is not a magic number. So number is not magic number. Yes, so that is our logic. So let us check. So first I can save this file, and here we can give the name as magic and number. So yes, that is, and C++. So yes, that perfectly. So let us check. I compile. Yes, there is no any error, and our exe file is generated. So Control F9, and we can check. First, I can check 1, 2, 3, 4. Yes, so that is a magic number. Yes, and you can also print the sum. Yes, here if you can print. So here that possibility. So here just sum. Yes, that our, and here you can also print, so you can get the idea that is sum is 1. And now I cannot give 1, it's not a magic. Yes, so yes, 1 2 operand output and input. So 1 2 3, so that is not a magic. So that number is not magic because that sum is 6. Yes, but that message and sum very close, so I give one blank. So yes, that possibility. So that save, yes, but here we can take as like first over, so 5011t, so that is a 0. So what happened in this case? So here that is a range is short because our integer range is a, positive 32,767, but our number is a 50,113. So that is a bigger. So that is a range issue. So what to do? So we can take as a higher range because that is a range problem. So here we can take long integer, yes, and that only require to uh, our n variable. So that is now let us check that perfectly work or not. So here again give a 50113. Yes, now that you can look that giving the answer. Previously that not taking the answer. So that is a perfectly. And now I check take as a watch window. So here alter W and that watch window. Yes, that we can first and then can know how to apply the watch expression, give the one by one variable, and first I give and then t and then sum. So and that also possibility alter W and we can take as output window. So our previously output. So now I can trace alter R. Yes, here trace into F7 function key. I press F7 key. So execute main and sum assigned to 0. You can look and watch window. And now n is scan. Yes. So we can give like 1, 2, 3, 4. Yes. How that apply this logic. F7, yes, that our condition is true because n is greater than and sum is 0, but one or logical or. So any one condition is true, so that while loop is true. If condition is not true because our number is 1, 2, 3, 4. So yes, that D first module, so 4 is separate, yes, and taking sum. Now sum is 4 because separate the digit module operator 4 at the last, our digit is separate and that store in sum. Yes, sum is now 4 and new number is 1, 2, 3. Yes, again that while loop continue. Yes, same. If condition is false, while is true, then 3 is separate and store sum is 4 and 3 7. Yes, and then new number 12. Yes, again while loop is true because n is new number 12, so n is not 0. So if is false and then 2 is separate digit modulo, so that store in the sum. So sum is 7 and plus 2 9 and then new number is only 1. So if condition is true, that if condition while condition is true, if condition is false and new means separate the digit is 1 and then 9 plus 1, so 10. Yes, and new number is 0. So that condition is greater than 0, but while loop is false. But here while loop is true again because here or, so that is sum is greater than 9. So yes, here 10, so that again continues. So that is very important, otherwise you can take second value. So that is not some student taking second while loop for 2 digit, 3 digit taking 3 while loop. That's not a proper solution. So now our if condition is true, n is equal to 0. So new number is 10 and sum assigned to again 0 and then continue to new number. So 0 store in the D and sum is 0 and 0. Yes, because D is 0 and new number is 1. Yes, that while loop is again continue same while loop. N is greater than 0. Yes, 1. So if condition is not true, yes, 1D and sum is 1 now and new number is 0. So both while loop now means while loop or both expression is false. That type I can do. So n is greater than 0, no, and sum is greater than 9, no, because only sum is 1. So while loop is false and sum is 1. So that is our magic number. So look here, our output is print. Yes, so that is our perfect logic. So that is I take as watch and output window, and now I can apply one remove one variable. Yes, in this logic, yes, that possibility. So improve to our logic. So first you can try the better logic to remove one variable, then remove one statement. then remove one if condition, and then loop. That is a process, means step by step. So here D is not required. Why? So we can give the D sum. I remove the one variable D sum, digit sum. So that is, you can also use sum, but I give the digit sum. So all I D sum, and what to do. So here how one remove the statement. So here this statement is not required. I remove this statement. Yes. So delete, and what to do. So here D is not required directly, and modulo 10. So that store. So why we can take one extra variable. So D sum, digit sum, and D is a remove. So that is the same. Yes, I save and compile. Yes, there is one. So sum. Yes, here we can apply D sum. So all where sum is there, so we can say there D sum, not, and you can use as sum. There is no any issue. So all are perfect. So let us check 640. That is our 3 digit. So that is a magic. Yes. And again, I use like 352. Yes, but 3 is extra. So that is not magic number. So again, I run, and yes, what to do. So yes, here that is typing. So I save, compile. Yes. So that is a directly. So 352. Now 353. Yes, that is not magic. Yes, that perfectly. Now I perfectly 352, not 3. So that is a magic. Just look. So this number is magic number. So yes, I think you can get the idea. And now I convert to the UDF, user defined function. So that is a, we can say that is magic. Yes, that type of UDF, and we can pass with argument with return data type, that type of, and what to do. So here we can scan, and then first I take as that all are well. So here we can say that D sum, yes, and that is magic. So we can pass as n, yes, and all logic I use in the our UTF. So that is a integer is magic, and that is I apply, that is a long integer, and the same long integer. Yes, I just yes, I declare only in integer. Yes, here we can also apply long integer, otherwise not proper, this range problem issue is created. So now all this logic here I first I copy and paste to in UDF, user defined function. You have to know very well. So here what to do. So here we can again declare as D sum. Yes, so that assigned to 0. And here what to do, here we cannot print. So if D sum is 1, so we can return as 1. Yes, and if D sum is not 1, so we can return as 0. So that perfectly. And now what to do, so all this logic I delete, and here D sum is 1, so that is a print we have to, let us sum. Yes. So let us check, and here we cannot print, so that is a 0 and 1 only. So that only message we have to print. So that perfectly. So let us check. I save. Yes. Anything else remaining? So all are well. Yes. No any change is required. So let us check. I compile. Yes. No any error. So again, I 1, 2, 3, 4. Yes, that the number is magic, but our sum is not print. So what to do? So we can also print in this technique. So here you can print. Yes, before you can pass, you can print the sum. Yes, that possibility. So D sum. Yes, and provide one blank. Yes, that, and provide else means brace. Same thing happen in the else part. So any one condition is true. So D sum, yes, one blank, and then print our message, and that close. Compile, yes, there is no any error. So again, I give like a 50113. So yes, one, the number is magic. Yes, that digit sum is at the last is a 1. So here also that chance to remove one statement where plus one. Yes, here not require the dsum. Yes, we can two time use both dsum. So what to do? So I remove this dsum and remove one statement. Yes, that possibility. So yes, very short technique. So I remove this and so where? So here directly I check is magic and pass the end. So directly if condition. Yes, if that return one, so this message is print, and that if condition is false, so that not magic number. So we can remove one variable dsum because we can use in both in our UDF and our main. So I remove and directly one statement. So calling in directly if condition because that return type is integer. So that is a possibility. Yes, there is no any error. So let us check. I 1, 2, 3, 4. Yes, that number is magic. So yes, very and now you can apply to yourself in the class. Yes, that possibility class you can apply the number is magic or not. Get and set. So print first scan one integer and print that check the put data or show and apply this logic. So to yourself. So very interesting. And one improvement here also you have to know here we cannot declaration. So what to do? So in UDF there are three main elements: declaration, then calling, and then UDF is a declaration, means definition of UDF. So I cut this definition and take before the main, so that like our class. So I define here. So one element I remove, means that declaration is now not required because you have to know here both two time declarations. So only semicolon is different in declaration and definition. So here now there is no needing this declaration. So compiler getting declaration and definition both in this one line. So now there is no any error. Yes, let us I compile. Yes, that third technique I improve to step by step our logic. So I compile and again run and give I any randomly number. So that is a not magic number. Yes, only six that answer sum of digit. So like we can say that 10 and 15, 15 plus 1 plus 5, so 6, yes, that's not magic. And last we can check to like our give any number. So like 604, yes, that is a magic. Yes, so 6041. So that is a magic. So yes, all are well, I think. So that is a magic number. We can step by step and very recursively technique sum of digit, same while loop that continue again. And that is our recursion digit of sum. So write this program to your in C++ notebooks if you prepare very interesting and very improve to develop to your logic number is magic or not. So first I take in the main, then I convert in UDF, and UDF we can also remove one statement, and then before the main we can remove the one main element of uh, the declaration of UDF. Yes, there is here no need to declaration of UDF. So all are well. And third technique is also you can apply to class, that very same logic, there is no change. So just convert into the class, declare one integer and sum in the class member and get and put or any UDF number and then apply to this logic. So now I close this file and yes, all are closed and quit. So subscribe my channel Ashok Sijalai, press the bell icon to never miss any update. Thanks for your watching, supporting, and sharing my video lecture. And any question regarding this definition or any in C++ concept to write in comment section. I give the definitely answer to you. Thanks for your supporting. Yes, and Hare Krishna.